just start by recording. Okay, so like I said, the mode of the class is that when we are doing 2011, physics 2011. So when we pick a particular question, the first thing that guarantee you if you can solve the question or not is for you to be able to identify the topic that the question belongs to. For that reason, when we pick a question, the first thing we want to do is to identify the topic that that question belongs to. So after identifying the topic that the question belongs to, the second thing is that you should be able to solve the question. And there's nothing that will make you be able to solve the question except you have a concrete understanding of that particular topic. So in order to satisfy that, once we are able to identify the topic, the next thing we are going to do is to summarize the topic. I put it in quote, summarize the topic in line with what Jamb will want to ask you on that topic. That is, the objective of Jamb for that particular topic. We are going to treat it, and then we look like maybe 10 to 15 questions under that topic, aside from the question that we answer. So after solving 10 to 15 questions under it, you are going to take assignment close to 28 questions or 30 under that particular topic. You are going to use it to practice. Then we'll move to the next question. So in a class, we can cover up to 3 topics or more than. Are you getting this now? So it depends on how voluminous Jamb focus on that particular topic will be, and how ready you also are. So those are the things that we are going to consider. So for this week, the whole of the lecture that we are going to have for this week is going to be on my YouTube channel for everybody to be able to watch. So in case network log you out or you miss the lecture, you'll definitely be able to access it on my YouTube page. Just this week lecture. Starting from next week, if you miss any lecture, you will be provided with the link that you are going to use to watch the lecture, but you will not be able to share the link with anybody. It's not going to be something that everybody can access. You see, the reason why everybody will not be able to access the lecture after this week is because 2,500 is too small for you not to be able to invest it in order for you to pass the Jamb. The class used to be 10,000 before, but we just like, okay, let's see how many people will be able to take the advantage of subsidizing the price for this year. So, and I pray that God is going to use it for you. So without wasting much of our time, let's get started. So I'm going to share my screen with you guys now. And once I share my screen and you can see my screen, just let me know that you can see my screen. One person is enough. So once you can see my screen, just let me know that you can see my screen. Then we are going to move on. Can you see the screen now?
Yes, sir.
All right. Okay. So here is physics 2011. Can you see 2011 Jamb physics questions? So paper type C. Now this year we have this to be year of paper and pencil. So paper and pencil, we always have different paper type, so that you are not going to have the same question as the person that is sitting beside you. That's the reason for all these paper type. So your own question number 1 can be that person question number 5. So and so on like that. That's the reason for the paper type. And there is a joke that we always crack then. We always be like, nobody in this life can fail number 1 question in Jamb. So Why do we always say that? Is it that the question is cheap? So let's see. So question number 1 here states that which question paper type of physics is given to you? So you can see the answer is already there, paper type C. So you just pick. Option C is the right answer to that. So there's nothing to treat there. So they are doing this so that they can know how to mark your script, because people with paper type B or paper type C or paper type E, they also have their own option to be different from yours. So that's the reason for that number 1 question. All right. So if that should be the case, let's move to the main work, and that is number 2 question. That is where the work starts from. And the question states that a carpenter, you can see, or you can just open the past question on the group so that you can follow up with the question. Question states that a carpenter on top of a roof 20-meter high dropped a hammer of mass 1.5 kilogram and it fell freely to the ground. The kinetic energy of the hammer just before hitting the ground is, take G as 10 meters per second square. So this is the question. Like I told you, whenever you read a question, the first thing you should do is to identify the topic. If you are unable to identify the topic, then you should know that there is problem already in solving that particular question. So how can you do in that case is something we are going to explain as we go in the class. But right here, we can identify this topic. The topic is under work, energy, and power. Are you getting it now? So the question is under work, energy, and power. So that means there's need for us to do what? To look at the topic, work, energy, and power. So when you talk about work, energy, and power, so I would like to open my other screen so that you can see. Okay. So here we have. So for work, energy, and power, that's what we want to look at right now. That's the topic, work, energy, and power. Work, energy, and power. So you can get your book now and pen so that we can commence now. Okay. All right. Now, when you talk about work, energy, and power, what exactly is the focus of Jamb on this particular topic? Work, energy, and power. Number 1, Jamb want to understand, they want to test if you understand how to go about calculating for work done by a body. They want to know if you understand when work is done on a body. That is, when you have a body, when can you say that work has been done by the body? Are you getting me now? When exactly can you say the body has done work? Jamb wants to know that. Are you getting it now? And thirdly, is that Jamb wants to understand, they want to test you if you understand the tricky way, that is convincing way of identifying if work is done or not. And secondly, which is that of energy, Jamb wants to understand if you know how energy is being transferred from one body to another. Jamb wants to know if you understand the conversion of energy from one form to another. Jamb wants to know if you understand the types of energy, and lastly, how energy can be transformed from one form to another. So those are the things that Jamb want to test you on energy. Then for power, Jamb wants to understand, they want to test if you understand what we refer to as transfer of energy, or the rate at which work is done. Can you differentiate between power and work done? Can you differentiate between power and energy? And lastly, what are the conversion units of power? Are you getting it now? All of these are what Jamb want to test. So once you are able to get all of this, then you are good to go. Am I making sense now? So these are things that we want to look at in tonight's class. So the first question is, what is work? So let us define it. And I'm going to be giving you two definitions, and I will also explain what you should watch out for in all these definitions as per objective questions on it. Number one is that work is the product. Work is the product of force and distance. Work is the product of force and distance in the direction of the force. I want you to note this very well. I want you to note this definition very, very well. Please pay attention here. There is difference between when you say force, work is a force multiplied by what? Distance. That is, there's difference between work is the product of what? Force and distance. And when you say work is the product of force and distance in the direction of the force. If the body, let's take for instance that you have a body like this. And pay attention, please. Let's say this body has a mass of m, and then you apply a force F. This body, before you can measure the kind of work done by the body, this body must also move in the same direction as the force. Are you getting this now? If this body did not move in the same direction as the force, then you cannot say the work done by this body is force times distance. So that you get what I'm saying clearly. Let's say when you apply force to this body, the body moves and gets to this point. Now, you know, the distance from here where you have the body before and this place is what we call D. Now, if they ask you for the work done by this body, the work done is going to be force multiplied by what? Distance. But you can say it is force multiplied by distance because this body moved in the same direction as the direction of the force. If this body moved in another direction other than the direction of the force, then you cannot say it is force multiplied by distance. For example, let me give you this instance. Let's say I have a body like this. This is mass M. And then you applied a force in this direction. This is force F. It's the direction in which the force is going. Then the body is now going in this direction. You can see the distance that the body is covering. Am I making sense now? You are applying force in this direction and the body is moving in this direction. You see that the body is not moving in the direction of the force. Are you getting this now? You can see that the body is not moving in the direction of the force. So in this case, if you say that work done is equal to force multiplied by distance, then you are going to be wrong. Are you guys following? You can unmute your mic and let me know if you are following, please. If you look at this first example, can you guys hear me and are you following? Okay, thank you.
Yes, we're following.
Okay.
Yes, I was following.
All right, thank you. So if you look at this first one, you see that we say work done is force times distance. Reason why we said it is force times distance is because that body is moving in the same direction as the force. But when you look at this second one, you see that the force is going upward in this direction, but the distance is what is moving in this direction. So you cannot say the work done there is force times distance. So what are we now going to say? For us to know what will be the force in this direction, we cannot say there is no work done. Are you getting this now? The fact that this body is not moving in the same direction as the force does not mean that what? Work is not done. Because what you need to check for you to know if work is done or not is that, is there application of force? If there is application of force, is there any movement? Yes, if there is a movement, then work has been done. Are you getting it now? So, but this time around, we want to calculate for the work done. Now, what you need to do is that you need to look for the equivalence of this force along this horizontal component. Are you getting it now? Let me take this out so that I can see. You know, the diagram is like this. This is the mass, M. The object is moving in this direction, in this distance. This is the distance the body is moving, and this is F. F is not moving in the direction of what? D. So for you to be able to calculate for the work done, you need to find the equivalence of F in this particular direction. So let's say this angle between this horizontal line and this what? Resultant force is theta. Are you getting this now? So if I take this down, you see that this place becomes opposite and here becomes what? Adjacent. So if I want to get the equivalent of this force along this horizontal component, then it's going to become F cos of theta. Because it will be adjacent over hypotenuse. That is, I will be having that cos theta is adjacent. Adjacent is the force along this horizontal component. So let's call it Fx divided by the hypotenuse, which is just F. So if I cross multiply, I will have that F cos theta is equal to Fx. So if that should be the case now, we already get the value for the force along this horizontal component. Are you getting it now? So we can now say work done is equal to F cos theta multiplied by D. Do you understand this now? So that means we have two formulas to calculate for work done. So we can use F multiplied by what? F cos theta multiplied by D, which D is what? The distance covered. Then we can also say work done is force multiplied by what? Distance. That is, if the force and the distance, they are, if the body moves in the same direction as the force, we have that work done is force times distance. But if the body is not moving in the same direction as the force, then you are going to have that F cos theta multiplied by what? D. So this is formula for work done. Do we get this now? Okay. So that is by the first definition of force, of work done rather. Now, let me clean this up. And then you look at this. We can also have that work done is defined as the product of force, and distance, the product of force and distance moved parallel, this is parallel to the line of action. To the line of action of the force. Of the force from a reference, from a reference. So do you get this now? So this definition that I have here is what bet this formula, W equal F cos theta multiplied by D. And the first definition is what bet this formula, force multiplied by distance. I want to believe that we understand this now. Can we move to the next line? Do you guys follow up to these points? Like, do you understand this now?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
All right. So let's move on to the next one. And how to understand when work is done on a body. Are you getting me now? So, like now, if you have that a man that is climbing staircase or an object taken to height. So if a man is climbing staircase, there is work done. Are you getting this now? Work is done when the man is what? Climbing what? A staircase. But you take an object from one point to another, work is done. When you stretch a string, work is done. Are you getting this now? When you what? Extend the surface area of a liquid. That is, when we talk about the surface tension of a liquid, work is done. When you remove electron from an atom against the atomic force, work is done. So what you just need to check out, because in most cases, that can be tricky and give you a question like, a man, I think that question is kind of very famous. A man carry his son weighing 750 Newton. Are you getting this now? A man carry his son weighing 750 Newton to watch a football match for 90 minutes. This question, you have what? Force. And you also have what? Time that the man takes to carry the ball. But the question is there any work done? Normally, if you put it in normal human sense, that is normal human thoughts, you think work is done. For you to carry something on your head for 90 minutes, you've done work. But scientifically, you've not done anything. Am I making sense now? Scientifically, you cannot what? You've not done anything. So, what it simply means is that you are just standing at a spot. You did not move. And once you are unable to move, you only applied force and the body did not move from that same position. What has happened is that you've not done anything. So you can see that the man carried the boy to watch the football match for 90 minutes on the same spot. He never leave that same spot. So since there is no work, there is no distance, we only have what? Force. Therefore, there is no work done. Do you understand that now? So work will only be done when what? There is application of force and at the same time, there is a distance. So no matter how tense it might be, don't make the mistake of saying work is done. So that's that. Are we together now? Now, another example of no work done is a man that is pushing a stationary wall. Because you need to understand all these things very well. This is a wall. And somebody now stand here, is pushing the wall. And the wall still remains at that fixed position. And the person is sweating. So the person is only sweating for nothing. No work is done. The person has not done any work. Are you getting this now? No matter how much effort the person wants to put in place to push the wall, no work has been done. Am I making sense now? All right. So another one is that When a woman carry a load on her head and it stand, just like the football match that we gave example of, no work is done. So in a nutshell, for you to know if work is done or not, you must always consider the distance, not just the force applied. You must also consider the distance moved. So if there is no distance moved by the body, now let me give a very tricky one. Let's say this is a man. This one is very tricky, and I want you to just get it now. Look at this man. He's carrying a load. This load, let's say the load is of mass 80 kilogram. Are you getting this now? This load is on this same horizontal level. Please pay attention to this very man, this particular one very well. The man is holding the load on his hand and he's walking. Are you getting this now? He's walking with the load, but this load remains at this same level. For you to get what I'm saying clearly, let's say this is the man and this is the load the man is carrying. From here to this place, let's say it is 2 meters, and from here to this place, let's say it is 3 meters. And this man is moving from here now, it's moving forward, but the level of this load remain at this same position, but the man is walking. So if Jamb wants to trick you under this question, they will say, what is the work done on the load? Are you getting this now? What is the work done on the load? So the answer is that there is no work done on the load. Are you getting this now? There is no work done on the load, but there is work done by the man against friction. The man is doing work against what? Friction. But there is no work done by the load, because it is the man that is changing position. The load is not changing position. So because it's the man that is changing position, the force that the man is applying to overcome the frictional force multiplied by the distance that the man covered is going to give you the work done by the man. But the work done on the load is going to be what? 0, because the load remained at the fixed position. Is that taken out? Okay, so if you have that a man descending with a load, let's say a man carried a load now and is just falling down freely, there's no work done also. I get it down. There is work done on the load, but there is no work done on the man. Do you understand that now? The load is doing work, but the man is not doing work. You can see that this first example, the man is doing work, but the load is not doing work. But the second example, whereby the man carried what? Load. And the man is just what? Falling down freely. Load is doing work, but the man is not doing work. These are tricky area in which Jamb wants to trick you to ask you question under this aspect of knowing if work is done and knowing if work is not done. Is that taken now? All right. So let's move to the next area. And this area is a way of asking you to calculate for work done by giving you a graph. So how can you calculate for work done if you are given a graph? Let's take for instance that I provide you with a graph of force against distance. Are you following now? If I give you a graph of force against distance and I ask you to calculate for the work done, please don't make the mistake of thinking that, yeah, exactly, that will let you understand that what is the work done by the load or what is the work done by the object, that is the man. So you just have to understand that whenever they put the question before you, and that's why you need to what? Get the question clear before you attempt it, so that you're not going to what? You're not going to get tricked. You understand that now? All right, so let's back to what I'm about to explain now. Now, when you have a graph, I want you to understand something now about graph. When you have a graph, there are two things that can be useful on a graph to calculate anything you want to calculate. And that is the slope of the graph and the area under the graph. The slope of the graph and what? The area under the graph. You see, when it comes to force against distance graph, and you were asked to look for the work done, you have nothing to do with the slope. Is that taken out? You have nothing to do with the slope. Because when you look at slope, slope is the change in vertical axis all over change in horizontal axis. I see this now. If I want to write this, I'll write it as force over distance. Am I making sense now? And force over distance will give you what? Seconds. It's going to give you, so let me just do that's mass times distance over time square, then divided by what? Distance. So that will just give you what? Mass over time square. So force over distance is mass per square seconds. So it's not having meaning to you at this level. Am I making sense now? It's meaningless. And that's why I said you have nothing to do with the slope when you are given a graph under what? Force distance. But what happened to the area? Remember, area is length times breadth. Now, area is length and breadth. Remember, work done is force times distance. You can see that when we look at the slope of the graph, we don't have anything like product of force and distance. But when we look at the area, the length, that is this particular side, that is F, multiplied by the breadth, which is this particular side, you have what? D. So you can see now that you have force times distance. Are you getting this now? Please, your question is sounding funny and I might not respond to it again. I'm teaching you this topic in respect to what Jamb will ask you. So Jamb is not asking you to plot graph, but they will give you questions that have to do with graph. You have to interpret it and solve whatever they ask you to solve with it. And that's what I'm putting you through. Nobody is asking you to plot graph here. Okay? So, if you look at this now, the area under this graph is length times breadth. So that is force multiplied by what? Distance. And you can see it gives you work done. So whenever you are given a graph and you are asked to calculate for work done as regard the graph given to you, all you just need to do is to calculate for the area under the given graph. So by calculating for the area under the given graph, you have your results to be what? To be the work done. Now, the area under the given graph depends on the shape that you have. Because they can give you some graph. You can have something like this, like a rectangle. I get this now. They can give you something like a rectangle like this. So if you have something like this, you should know that your work done, that is area under this, is going to be length times breadth. Because area of a rectangle is length times breadth. If it is also a square, it is also going to be length times breadth. And if your graph is like this, let's say you are given a graph like this. This is your graph. If you look at this graph, it's the shape of what? Shape of a triangle. So the area under this graph is going to be what? Half base times height. That will be your work done. Am I making sense now? Half base times height. You can have what? Your graph to look like this. So if you have your graph to look like this, don't mistakenly say the answer is 0, because this is how tricky Jamb can be. Are you getting this now? Because you are smart and you know that when you have a curve like this, the slope of the graph is going to give you 0. Please, it is the area under the graph that you are looking for, not the slope. So don't see this curve and think the work done is going to be 0. Am I making sense now? So for this one now, it's going to be what? Area of a semicircle. So the work done at this point is going to be what? 1/2 pi r square. Are you getting this now? Or 1/2 pi d square over 4. Are you getting it now? Where d is the diameter of the circle. You know, radius of a circle is diameter over 2. So if I square what? If I square the radius, I have to square this also. And I will have what? This square all over 4. That's why I said, is that your formula is what? 1/2 pi r square or 1/2 pi d square over 4. That is if you are given this kind of a graph. And you might be given a graph that also looks like this. Can you see this now? This is a trapezium. Am I making sense now? This is what? A trapezium. Then your work done is going to be what? Let me label. Let's say this is A. Can you see that now? And here is what? B. And you have your height H. So for the area, okay, let me redraw this diagram so that you can understand. Because trapezium can come in different form. So if you have this is a trapezium. You can have this. This is also a trapezium. You can have this. I see this now. This is also what? A trapezium. So trapezium is the most tricky shape of graph that you can have. So you have to be careful and watch out for it very well. So if you have a trapezium, let me call this point A, this short side, I call it A, and this long side, I call it B. And this is the height of the trapezium. And here, this is A, this is B, and this place is going to be the height of the trapezium. And this one, this is going to be, if you look at this now, look at this carefully, please. This is going to be your A. Can you see? And this place is going to be your B, and this is your H. Because if you look at this one very well, it's just like the reverse of this. So you have to be careful very well. Am I making sense now? So this is the height of the trapezium, because if I redraw the shape now, you see what I'm saying. Can you see? So this is like what you have here. Am I making sense now? So this is A, this is B, and this is your H. So what is the area of a trapezium? The work done is going to be 1/2 into brackets A plus B multiplied by what? H. Are you getting it now? So whatever result you have here is going to be your work done. Class, do you understand this now? So when they give you graph and you're asked to look for work done, your work done is the area under the graph. Please, if that is clear enough, somebody can just unmute his or her mic and let me know if it is clear so that we can move on.
Yes, sir, it's clear.
All right. Okay, so
it's not clear. It's not clear.
Okay, so what was not clear to you? Can the speaker speak up? What was it that is not clear to you? Can I know, please, so that I can explain fast?
Okay, the area of where the points of that graph meet. That's the last one, the last graph.
This particular one?
Yes, this part. Yes, this one.
So what's not clear there?
Where the points meet, like the A and B. I was not, wait, I won't lie, Sha. I was not there.
All right, so
I was not around.
From here, you can see that here we have a short side, we call it A. We have the long side that opposites it, we call it B. I see it now. Here also, we have a short side, we call it A. We have a long side that opposites it, we call it B. Why? This is the height. Can you see? So if the graph presents itself in this manner, remember all these graphs, they are force times distance. Please note that they are all force times distance. That is force against distance. Force against distance. Force against Distance.
Distance.
Yeah. So if you have A here, if you look at it from here to this place, is the short side. That's why we call this point A. And if you look at the side that opposite it, is the long side, and that is what? B. So the height of the trapezium is going to be from here to this place. That's H. And this is the formula that suits any of the shape of this trapezium. Because that's the formula for calculating the area of a trapezium. And whatever result you have with this is going to be what? Is going to be your answer for the work done. I believe I'm clear enough now.
Yes. Thank you very much.
All right, you're welcome. So we'll move to the next one. And this next one, we are still under how to calculate for work done. Now, examiner can be tricky at times, and they will not give you the distance directly.
Everything is in the body.
Are we together now? They will not give you the distance directly. They can give you the distance in terms of some other parameters. Let me quickly recall something to you so that you guys see what I'm saying. Work done is force times distance. Now let's take for instance that in the question, the examiner did not give you, what's it called? The examiner fails to give you distance directly. And the examiner is now giving you something like velocity, acceleration, and you are asked to calculate for work done, of which you have been told in the class that work done is just force times distance. So how can you relate to that? Note that your distance can come like this. If you are given acceleration and time, then your distance is going to be 1/2 AT squared. Are you getting this now? If you are given
Excuse me, sir.
I'm listening.
Must the graph be shaped? Must it be always shaped with triangles and Pythagoreans? Or what is this called?
The graph can take any shape. It's called a graph and it can take any shape. So I only give you some examples of likely shape that the graph can take. The graph can take a rectangular shape. It can take a triangular shape. It can take a semicircular shape. It can take a trapezium shape. And that's why I gave you all the formula to calculate the area of those shapes. Don't worry, when we start looking at questions, we might see questions that has to do with that so that you understand what I'm saying better, so that we can move on. Is that taken?
Thank you, sir.
You're welcome. All right. So if the distance that you have, let's say in the question, you are given acceleration and you are given time, and you are asked to calculate, and then they also gave you force, and you are asked to calculate for what? Work done. In that case, your distance is going to be 1/2 AT squared. So that means that work done is going to be force multiplied 1/2 AT squared. Done. Now, what if they don't give you acceleration, but they gave you what? Gravity and time and force. Your work done is going to become force multiplied by 1/2 GT squared. Okay, again, if the examiner gave me velocity and acceleration instead of time, then your work done is going to be force multiplied by V squared all over A. I said this now. What if the examiner gave me velocity, time, and then gravity and force? Then your work done is going to be force multiplied by velocity squared over gravity. Are you following all this now? Okay. That's that for examiner changing distance. What if the examiner want to change force? Or is it of the time that they are going to be giving us force as F? Absolutely no. Are you getting this now? So there are times that they are going to give you force in form of friction. Are you getting this now? So if you are given force in terms of friction, remember that force is coefficient of friction multiplied by normal reaction, where normal reaction is given as mass times gravity. So if this is what you have in relation what to friction, you have that your work done is mu times mass times gravity, then multiply by distance. Do you understand that now? Mu is called coefficient of friction. You'll be given in the question. All right. So these are ways that you can have questions under work done. Are you getting it now? So let us move to the point of energy. We have been able to cover the aspect of work now. So let's cover the aspect of energy. Energy. Now, when you talk about energy, what is energy? Energy is the ability to do work or anything that is capable of doing work. Are you getting this now? Anything that you see that is capable of doing work, that means that thing possesses what? An energy. When there is no energy, there is no work. And when you see work, it means there is what? Energy. That is why at times we can say our work done is equal to energy. Do you understand that now? I want you to please remember this very well. Your work done can equal to energy. Why? Work done is energy is the ability to do work. And whenever you see work being done, it means energy is possessed. Do you understand that now? All right. So if you understand that now, energy cannot be normally be destroyed. I want you to understand that. You know that from the law of conservation of energy. That is what? Energy cannot be normally be destroyed, but can be changed into another form. Are you getting this now? So energy can transform from one form to another, but you can't destroy it. It's not possible to destroy what? Energy. But it can transform energy from one form to another. Am I making sense now? All right. So if you understand that now, that energy cannot be destroyed, but it can be transformed from one point to another, what other thing do you need to know about energy? There is need for you to know that there are what we refer to energy that we use to do work. When you refer to energy that we are using to do work, you are referring to what we call mechanical energy. Are we together now? So mechanical, we have what we call mechanical energy. Now, when you see this mechanical energy, this is the energy that you possess when you are doing work. Jamb can put it to you that what's the type of energy possessed by a carpenter? What is the energy possessed by somebody? So long that that person is doing work, it is what? A mechanical energy. And mechanical energy can be divided into two: potential energy and what? Kinetic energy. You see these two, it's not possible for a body to possess the two simultaneously. That is, the two, they are inversely proportional to each other. Whenever you have potential energy in a body increase, kinetic energy of that body will decrease. And whenever you have what? Kinetic energy of the body to increase, potential energy of the body would decrease. Am I making sense now? Are we together? So we say potential energy is the work done by a body because of the change in its position. Are you together now? Potential energy is the work done by a body because of what? The change in its position. And we can also say that potential energy is the ability. Somebody wants to say something? Okay,
No, sir. No, sir. Continue, sir.
right. So we can also say that potential energy is the ability of a body, that is the ability that a body has to do work, the potential of doing what, of doing work. That is a stored energy, a energy that can give you room to do work. I don't know if you understand what I'm trying to say. The energy that a body possesses in order to do work, you can also refer it to what? Potential energy. Am I making sense now? So energy that has to do with what? Change in position of an object is what we refer to as potential energy, or the energy that a body possesses in order to do work. So that's what we refer to as potential energy. What of kinetic energy? Kinetic energy is the ability a body possesses to do work because of the movement of its molecules. So when you are in motion, the kind of energy you possess when you are what? In motion is kinetic energy. When you are not moving, when you are static, the kind of energy possessed is potential energy. Now, let's take for instance that you have an object here now. This is the ground floor. This is ground level now. And this is height. I say this now. If you pick this object from this point and you take it to this height, you know, you have taken its position from ground level to what? To the top level. This body at this point is having what we call potential energy. Are you getting this now? At this point, the body is having what? Potential energy. And that's why we say what? It is the energy that deals with what? The change in position. So now, if this is what we have, we said it earlier that whenever kinetic energy increase, potential energy will decrease. And whenever potential energy increase, kinetic energy will decrease. What type of force can give us increase in potential energy and decrease in potential energy? The kind of force that can produce that is what we call conservative force. So any force that we call conservative force, they are forces that are capable of increasing, are you getting it now? And also do what? Decreasing the energy of a body. So with this force, energy will remain conserved. And that's why we can say mechanical energy is equal to potential energy plus kinetic energy. At the point where potential energy is maximum, kinetic energy will be what? 0. Then you can say mechanical energy is equal to potential energy at that point. At the point where kinetic energy is maximum, potential energy will be what? 0. Then you can say mechanical energy is equal to what? Kinetic energy. But the case whereby they are not maximum, mechanical energy is going to be what? Potential energy plus kinetic energy. Do you understand this now? So don't get it twisted. So it's as simple as that. Now let us go into what? How to calculate for all these things. How do we calculate for kinetic energy? How do we calculate for potential energy? So let's look into that. Now, when you talk about the formula to calculate for kinetic energy and potential energy, since kinetic energy has to do with the movement of molecules, either by translational motion or rotational motion or vibratory motion, we have that kinetic energy is 1/2 mv squared, where m is the mass in kilogram and v is the velocity in meter per seconds. And then we have that potential energy is energy that deals with gravity. I want you to pay attention to this. Potential energy is produced by anything that has to do with gravitational field or anything that has to do with elastic. I want you to know that very well, because those are one of the tricky aspects that Jamb will want to ask you questions. that might kind of look it might look kind of tricky. So you need to understand that potential energy, it has to do with gravitational field, because gravitational field is a conservative word. The kind of gravitational force rather is a conservative force. So for that reason, potential energy has to do with what? Gravitational field. The same thing goes to elasticity. Are you getting this now? Potential energy is also related to what? Elastic material. Are you getting this now? So when you have an elastic material, the kind of energy there, for example, they can tell you that when a man wants to fire a catapult, calculate for what? The energy stored in it. So you know they are referring to what? Potential energy. And that's to tell you that you are under work energy and power. A question can take you to gravitational field or can take you to elasticity. You need to understand that. So we have that potential energy is given as what? Mass times gravity times height. Are you getting this now? Or if you have that gravitational potential V, this capital V is not small v, capital V is to represent gravitational what? Potential, and is given as what? Small m multiplied by what? Capital M all over D, where D is what? The distance. Am I making sense now? So this gravitational potential is also equivalent to what? Potential energy. So you can say mgh is equal to mgm all over D. So this and this can cancel. Then you have that gh is equal to what? Gm over D. So don't let us go into gravitational field. Just let us stop here by saying potential energy is equal to mass times gravity times height. And you can also see potential energy is equivalent to this when you are comparing it on a gravitational field. Is that taken now? All right. So if that should be the case, we can also look at it in line with if you are given an elastic material. If it has to do with elastic material, then potential energy is going to be 1 over 2 Fe, where E is the extension. Or you have that potential energy is equal to 1 over 2 Ke squared. Or you can also have that potential energy is equal to 1 over 2 F squared over K, where K is the force constant. Am I making sense now? Now, the last part of this, before we start looking at transformation of energy, is that it's possible that potential energy transforms to kinetic energy. I want you guys to pay attention to this point here. It's possible that what? Potential energy transforms to what? Kinetic energy. For example, I'm sitting down after eating. Are you getting this now? And all of a sudden, I stand up and I start walking. So what happened? I convert my potential energy to kinetic energy by getting up and start walking. So in that case, if Jamb want to trick you, Jamb will give you questions that totally look like potential energy. Like Jamb can give you mass, gravity, and height. And they will now ask you to calculate for the kinetic energy of the body. So when they put such question to you, you should know that Jamb is referring to what? A potential energy that converted to kinetic energy. So if they are referring to that, then you can say potential energy is equal to kinetic energy. In that, you can say mgh is equal to 1 over 2 mv squared. Do you understand this now? And this is another case that Jamb can give you mass, they can give you gravity, they can give you height, and they will ask you to calculate for velocity. And you'll be asking yourself, how will I do this m? Because m is not part of the equation of motion. You should know that you have to equate potential energy to kinetic energy. All these are tricky way that Jamb can want to ask you question, might want to ask you question under this topic. So pay attention to them and grab it once. Does that make sense to you? Now, the last part of this calculation of energy, and I hope everybody is jotting things down, though the recording will be available so that you can rewatch it in case you want to refresh, especially when you want to deal with the assignment that will be given, because you need to submit the assignments tomorrow on the group. All right. So the second case of energy, after all these ones we've considered, is when you want to consider energy and collision. Am I making sense now? Energy and what? Collision. So in that case, when we are talking about, for example, let's say I have this object here, and then this is a ball. If this ball should hit this object, this ball is doing a positive work on this object, because the force that you applied on this ball to hit this object is moving very fast towards the positive axis. Therefore, the work done there is going to be positive. But there will be collision between this ball and this box. So when collision occurs, the collision that occurs is the force that this box applied on this particular ball. In that case, the ball is going to retard to this direction, Abi, because of the force applied by this one, by this box. So it's moving towards the negative side, and at the same time, the speed will reduce. Therefore, the work done on this ball by this work, by this force, is going to be a negative work. So when you are having this kind of a case of collision and you are have to calculate for work done or calculate for something, you don't need to stress yourself. Just say force multiplied by distance is equal to 1/2 mv squared. Is that taken out for inelastic collision? All right. So if that should be the case, I think that's a good place for us to stop under calculation of potential energy and kinetic energy. Now, the next thing you need to understand, let us look at energy transformation. I will consider some tools that I feel Jamb always asks. For example, if you have steam engine, if I have steam engine, I want you to memorize this very well. Number one, steam engine. What is the what's it called? Transformation of energy in this one is that it's going to move from what? The steam energy transfer its energy to mechanical energy. It transforms its energy to mechanical energy. Now, let me see if I can really break this one down for you very well before I move on. Okay, let me see. There's a way Jamb always presents this for you. Jamb might present this as steam engine drives a generator. They might not want to call it steam engine directly. They might want to like the application of this steam engine, like using the steam engine to drive a generator. What will be the energy transformation? So the energy transformation here is just going to be from heat energy, it is transformed to kinetic energy. Then from kinetic energy, it's going to transform to electricity. Then from electricity, it will become what? Heat energy again. That is, the electricity is going to form what? Heat energy. And then it's going to give you what? Light. You see now, from heat to kinetic direct, they now bring in what? They now bring in generator. I can't recall the way they normally phrase the English. Like steam engine drives a generator, or steam engine drives generator. I don't know, but there is a way they always cast the question in such a way that they are relating steam energy to what? To generator. And you know what generator does? It provides what? It helps us to generate light. So instead of you just to know that, oh, steam engine, the transformation of energy from it is from heat to mechanical what? Energy. Understand that the process will be more than that when it comes to the application of sun. So it's going to transform from what? Heat to what? Mechanical energy, which is kinetic. Then from kinetic to what? Electricity. From electricity to what? Heat. Then from heat to what? Light. So that's that about what? Steam engine energy transformation. Another one is striking matches. Striking matches. So all these things are what you might not pay attention to, but that is where Jamb might want to show up under this particular topic. So what matches does, it converts what? Mechanical energy. It converts it to heat energy. You get this now? From mechanical to what? To heat. Then let me see if I can give you more. Solar cell. Solar cell. So all of this converts. This converts heat energy to electrical. Energy to electrical energy. Then fourth one, electric fire. Electric fire. This one transfer what? Electrical to what? To heat. So basically, for you to be able to like know what energy transformation will occur, you just need to take your time and look at what is the working principle of this particular thing. How does it work? Are you getting this now? So chemical cell. Okay, I think another famous one is microphone. So I just want to give you something you can relate with. Microphone, for example. Microphone transform what? The sound energy to what? To electrical. Are you getting it now? Then telephone earpiece.
Sir,
I'm with you.
I don't understand how that microphone converts sound energy to electrical energy. So it's not electrical to sound. I'm confused.
Okay. Are you done? Is that your question?
Yes, sir.
All right. If you say microphone transform what? Sound to electrical. Now, if you don't plug your microphone and you produce sound to it, is it going to work?
No.
Huh?
No. Yes. Sometimes.
Sometimes? All
So
right.
I
So
don't.
okay, let me break it down. So
Microphone.
let me break it down so
Let
that
me
you're going to
tell
understand.
you, it's supposed to be electricity. It's supposed to be electric to sound, not sound to electric, because we have to plug our microphone first before it bring our voice, before it bring our sound. So I go with her that she says it's supposed to be electric to sound, not sound to electronic.
All right. Okay. So listen now. Listen to the breakdown now. Are you there?
Yes, sir.
All right. So this is your speaker now. When you speak inside your microphone, do you hear through your microphone?
No, with our ears.
Do you hear through your microphone? Is it your microphone that you always used to hear, or you hear from the speaker?
You hear from the
From the
speaker.
speaker.
Okay, so the speaker is not microphone. So the microphone helps you to collect your sound, and it converts it to electrical energy that can be supplied to the what? To the speaker. Is that taken now?
Yes.
Like, do you get it clearly now?
No, sir.
Okay, let
No,
me
I don't think get it because I
calm
will not
down,
lie to you.
calm
I don't
down.
get it.
If you want to get it, forget about what you have in your mind. I already forget what I have in my mind. So I want to say, let's go to the real world now. When you speak inside a microphone, do you hear through the microphone?
No.
You
I hear
hear
through the
No,
speaker.
you hear through the speaker. Okay, so look at the screen now. This is you. Are you getting this now? This is the
yes, sir.
microphone. This is the
Yes.
microphone. Okay, let me redraw the microphone. So this is the microphone. This is you. This is the speaker that people will hear from. Are you getting this now? You are the one
Yes.
producing the sound.
Yes.
I see it now. And you want the sound to go to this particular speaker. Are you using electrical energy? What energy do you produce? You produce what? Sound energy. Are you getting it
Yes,
now?
electrical energy.
Now, you
Yes.
produce sound energy.
Electrical sound and
Calm down.
electrical energy. Yes.
Your speaker is receiving electrical energy from where? From the microphone. Are you getting it now? So when you put
Yes.
this,
From
when
the
you put
sound.
the sound energy inside the microphone will convert that sound energy to electrical energy and put it inside the speaker. And the speaker is going to produce what? Another sound energy that everybody can hear. So do you understand the chain now? You are producing
Yes,
the
sir.
sound, the microphone is helping you to convert it to electrical energy that the
A
speaker
little bit.
understands,
Yes.
and the speaker will help you to convert it to what? Sound energy that everybody can hear. It's clear now.
Yes, sir.
Okay, so
Yes.
Thanks, sir.
thank you for asking that question, because some people might also be confused about it, but the fact that you ask now enable them to also understand, and that's why we say let's make the class interactive so that everybody can what gets to understand. That's how crazy Jamb can be, and those are the kind of tricky questions that they always like put forward for every individual. So now the next one is going to be okay, let's say electric motor. So I'm trying to think of the ones that are very familiar, uh, like things that are that we can find around us, and those are the things that they might want to use. So this one is going to convert to electrical to mechanical. So I think I will stop here. There are still more that you can look into. Like I think what's it called? They might want to look at. Okay, there's this particular one that I think I've seen before in one of their pack. Can I clean this now? Okay, let me just adjust it on here.
Yes.
Okay. I think I want to remember one about electrical generator, like generating electricity. Okay, hydro electric hydroelectric power station. So examiner can put this to you that what is the energy transformation in what? In a company or industry where they make use of what? Hydroelectric power. When I say hydroelectric power, that is they are producing their lights with water. They are generating current with water. So what will be the energy transformation there? So the energy transformation there is going to start from mechanical. So that is kinetic, a running water. Are you getting this now? So a running water, they collect it together. When they collect it together, it becomes what? Mechanical. Are you following now? So after collecting this together, it becomes mechanical. Then from this mechanical, it becomes what? Electrical. Are you getting this now? And from being electrical, it results to what? Light. So kinetic energy to mechanical energy to electrical energy to what? Light energy. So that's going to be energy transformation for hydroelectric power station. So you can do more by probably checking your textbooks for more of such, or you look at more of Jamb past question. I think audio question we are going to be given as assignment is going to be what? Jamb question. And if you are watching this on YouTube right now, you can check the description box for the I think about 30 questions like that, or 28. They are all from Jamb pack. So some of these questions can reflect them. All right. So let's try to move as fast as possible to the next area that we might want to talk about, and that's the aspect of what we call power. Yeah. So power. Okay. So power. Now I want you guys to understand something about power. When you say power, power is the transfer of energy, the rate at which energy is being transferred. Are you getting me now? the rate at which what energy is being transferred. That is what we refer to as power. And we can also say power is the rate in which work is done. Power is the rate in which what work is done. That's why at times we say power, or in most times we say power is equal to work done all over time. Are you guys following? Work done over time. That is what we call time. That's what we call power. But for you to understand this, you can also say it is energy over time, because we define it as what? As the rate in which energy is being transferred. Now, I want you to understand when they say somebody have power. The fact that you have power than me does not mean that I can't do what you can do. Please get that part. The fact that you have power does not mean you can work than me. But it means you can work faster than me. Have you seen the difference? We are going to do the same amount of work, but you can do that work faster than I'm going to do. That's what we refer to as power. So get this clear now. For example, let's say, okay, Miracle has been contributing to this class since. Let's say Miracle. And
Sir?
I'm using your name as example. Okay?
Okay.
Let's say Miracle and what was it called? Oh, okay. Let me say Dolapo. Okay, Dolapo is here with us. So Miracle, you do work of 100 joules. Dolapo also do what? Work of 100 what? Joules. I see this now. But it takes the work you did is 100 joules. The work Dolapo also did is what? 100 joules. You both did the same work. But it took you 1 second. It took Miracle 1 second to get this job done. But Dolapo took 50 seconds to get the job done. Are you getting this now? Let's see the person that has the highest power between them. They both do the same amount of work, isn't it? But Miracle get her own job done in 1 second, while Dolapo get her own job done in 50 seconds. So let's calculate for power of Miracle. That will be 100 over 1. So Miracle is having power of 100 joules per second. While Dolapo, our power is 100 over 50. So that means Dolapo is doing work of 2 joules per second. So can you see now that for us to say that Miracle is powerful than Dolapo is because Miracle is transferring energy of 100 joules in 1 second, while Dolapo is transferring what? Energy of 2 joules in 1 second. Do you understand that now? So when I say somebody is powerful, it means the person is doing what? Is transferring energy very fast. And when I say somebody does not have power, that means that person is transferring energy very slow. So transfer of energy is what we refer to as power. Am I making sense? Do you get that now? All right. So let's go to tricky way that Jamb wants us to fail this simple thing. So we have seen the formula for work now. We see that work is given as what? Power is given as work done over time, or we say power is energy over time. All right. So we can also say that power is equal to force multiplied by velocity. Many people don't know this, but I will show you. Why is power force times energy? Force times velocity. We are looking. Someone wants to say something? Miracle. Okay. All right. So power is work done over time, right? So work done is given as force times distance divided by time. So if you have force times distance divided by time, this is equal to force multiplied by distance over time. And distance over time will give you what? Velocity. That means that power is equal to force multiplied by velocity. I hope that is clear. So that's another formula for power. So the last but not the least is that we can also say power is equal to mgh over time, that is potential energy over time. We can say power is equal to mv squared over 2t. That can also be formula for power. You can also say power is equal to IB, that is current times voltage. You can also say power is equal to I square R, that is current square multiplied by what? Resistance. So these are formula for calculating power. Is that taken out? All right. So knowing this will help you to go far when you are dealing with questions on the energy, work energy, and the power. All right. So the last part that I want to talk about is the conversion of energy before we look at questions under this topic. So conversion of what's it called? Units. Like for example, 1 watt, normal unit for power is watts. So 1 watt is equivalent to 1 joules per second. I get this now. 1 watt is equivalent to 1 joules per second. And 1 kilowatt is equivalent to 1000 watts. And 1 megawatt is equivalent to 1 million watts. That is 10 raised to power 6 watts. Are you getting it now? And the last one is when you say, okay, who is that? I think somebody mic is open. Epogie. Did I pronounce your name well? And what was it called? Daniela, kindly mute your mic. Miracle, mute your mic. I'm using headset, so that noise is disturbing my ear. Thank you. So back to what I'm saying. So 1 watt is equivalent to 1 joules per second. 1 kilowatt is 1000 watts. 1 megawatt is 1 million watts. Then 1 horsepower. 1 horsepower, that is 1 HP, is equivalent to 746 watts. Are you getting that now? Approximately 3/4 kilowatts. Those are the units conversion. Miracle, do we offend you? Can you mute your mic or I mute you? All right. Okay, so that's about what? About conversion of units under power. All right, so let's take questions now. But before we take question, let's go back to the original question that we started with. So that will be our first question to look at. We are told that, can I copy this? Let me see if I can copy it. Okay. Control C. All right, so let me just copy it and come down to this playlist. Okay. Control Z. Okay, sorry. I'm trying to copy that particular question so that we can look it together here. Okay. Okay. Oh, sorry. It's like this PDF is locked. All right, so no problem. Let's just read and see. The question says a carpenter on top of a roof 20-meter high. So I want to solve this question now, guys. So look up. The carpenter is on the top of a roof 20-meter high. So the height of the roof is 20 meters. So what's the next thing? Okay, the height of the roof is 20 meters. Or can somebody help me to read? Can you just open the PDF and read to me, please? Do we have somebody that will do that?
A carpenter on top of the roof.
All right, thank you. Write down. A carpenter on top of a roof.
Sir, please can you show the question again so I'll be able to read it?
A carpenter on top of a roof,
Okay.
20-meter high,
Okay.
dropped a hammer of mass 1.5 kilogram.
The mass of the hammer is 1.5 kilogram.
And it fell freely to the ground.
Okay.
The kinetic energy of the hammer just before hitting the ground is dash. Gravity is equals to 10 meters per second square.
Okay, thank you so much. Now, who can tell me how we can go about this? Who can help us? Which formula are we going to use? We have.
You can use
Okay.
Potential energy.
Okay, we can use potential energy. What's the potential energy?
So we'll use KE is equals to MGH.
Okay, so we can use KE equal what? MGH. So guys, do you see what I just told you earlier? I said, you know, this question normally.
K is not huge.
Yeah, KE, you can use KE. You know, KE is 1/2 mv squared, right? And I said, Jamb can be tricky at times. They would like give you question that is supposed to use what? MGH. That is potential energy. And they will ask to calculate for kinetic energy. So you should understand that potential energy at that point is equivalent to kinetic energy. That's the case whereby potential energy transforms to what? Kinetic energy. Do you understand that now? Do you understand that?
Yes, sir. Yes, sir.
So for those that said we are going to use potential energy MGH, and for those that said that KE is equals to MGH, we are both correct. So those are the things I always like let you understand when I was explaining. So at this point, we have that the kinetic energy just before reaching the ground is 1.5 multiplied by gravity, which is 10, multiplied by height, which is 20. Then we have 1.5 times 10, that will give us 15. Then 15 multiplied by 20. 15 multiplied by 20 will give us what? Everybody pressing calculator there for us.
Try to give us 300. 300.
300, right? So
yes.
The answer to this is 300 joules. So do we have 300 joules to be part of the option?
Hello, sir.
I'm listening. Who is that?
300.
I did it a different way.
D is 300.
Yes, 300.
All right, so that should be the right answer to the question. Somebody saying something.
Yes, sir. I said I did it a different way. And I told the same thing as like 300.
Okay, you get your 300.
Yes, because I used of motion. E squared is equals U squared plus 2s.
That's long journey. That's long journey. You only do that when you don't understand that potential energy can be converted to what? Kinetic energy. Are you getting this now? And that will take more of your time. You can see this one is just straightforward. You are right. The procedure you took is what? Correct. But you know, it's not healthy as a jambite because of time factor. Is that taking off?
Yes.
So let's look at the first question here and let's see. So the question here states that which of the following, can we see the screen clearly? Which of the following,
yes, sir.
which of the following statements correctly defines quantitatively the work done by a force? The product of the force and the distance moved. A, parallel to the line of action of the force from a reference point. B, perpendicular to the line of action of the force from a reference point. C, on a line through the reference point. D, by the object. Which one will be correct? Do we get that clear?
Sir, A is the answer.
A is the answer. Do everybody support her?
C.
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 Is that what?
C
C.
is the answer.
C.
Yes.
C.
Okay. C, on a line through the reference point. A, parallel to the line of action of the force from a reference point. You know, we look at this, and that's the first thing we look at the beginning of the class, Abby. And now I gave you two definitions for work done. The first one, Jamb already gave it to you. They said what? The product of force and the distance moved. The second one, the what? The force parallel to the line of action of the force from a reference point. So C cannot be the answer. On a line through the reference point, that is not correct. So the correct answer to that question is A. That's the right answer. So those that choose A, kudos. Is that taken out? For those that choose C, have you seen why you are wrong? Okay, so question number 2. Are we there?
Yes, sir.
Okay, and I think this should be answered by smart ones. A stone of mass m kilogram is held h meters above the floor for 50 seconds. The work done in joules over this period is
0.
0.
Do you all agree that it's 0? Why is it 0?
Because there was no work done, sir.
Because there's no work
Yes.
done. It just remains in a fixed position. Okay?
Yes.
All right, so let's look at another one. Question 3. The poem states that a constant force of 40 Newton. Somebody pick biro. You guys should pick your biro now. You have to answer this very fast. A constant force of 40 Newton. The force is 40 Newton. Acting on a body initially at rest gives an acceleration of 0.1 meter per second. The acceleration is 0.1 meter per second square. 4 seconds. The time is 4 seconds. Calculate the work done by the force. Calculate the work done by the force. What's the right answer to that?
It's joules.
Somebody say 8 joules. Is that what we all have? Is it part of the option? That's option A. Is that
32,
correct?
sir.
Somebody say 32.
Yes, sir.
Okay, it's an answer. We have 2 options now. It means you want me to solve. Another person? Do you have any other answer?
Still on it, sir.
Okay, still on it.
Yes, sir.
91-minute question, so you need to be very smart.
Thirty-two, sir.
32, sir.
32. Okay, so
Yes, sir.
does that mean that the person that choose 8 is wrong? Please check your work again. The person that chose 8, the person that chose 8, the person that chose 8, do you cross check your work now?
Yes, sir. It was a mistake.
Okay, so what was your mistake before?
I didn't square the time.
Okay, you didn't square the time. So the correct answer is just what? 32. You see now that we have nothing to fear about when it comes to Jamb. So it's always so direct. It's always so direct. They can't ask you above all of those things. They can only be tricky. It can only be tricky. Okay, let's go to question number 4. Okay, the question says the area under a force. So, okay, the area under a force distance graph represents A, acceleration, B, velocity, C, power, D, work done, E, momentum.
Work, sir.
Okay, so I think we explained that in the class as well, right?
Yes,
Yes.
sir.
So you don't need to like waste your time at all. So that's just it. Question number 5. So the question states that a force varying linearly with the distance acts on a body as shown in the figure. Okay, as shown in the figure. The work done on the body by the force during the first 10 minutes of the motion is, okay, I'm trying to find the figure. Okay, a force varying linearly. So this is the figure here. Okay, let me try to draw the figure. Sorry for my laziness. Okay, sorry. Right, so here is the figure. Okay, that's a straight line. So this is 10. This is 20. Okay, and here is 5. Here is 10. Here is 15. And here is what? 20. Okay, so can you solve now? This is a question now. The question says a force. Remember, what we have here is force, and what we have here is what? Distance. Yeah, distance in meter, and this
200,
is force,
sir.
force in Newton. Okay, somebody said 200.
Yes, sir.
Okay, is that what everybody gets? Go to the question again. A force varying linearly with the distance acts on a body as shown in the figure. The work done on the body by the force during the first 10 minutes. Sorry, during the first 10 meter. This is meter, not minute. During the first 10 meter of the motion is, no, it's during the first 10 meter.
200. So the answer is 200.
Okay, somebody else also gets 200.
Yes, sir.
Okay, is that what everybody gets? Is there any other answer that contradicts that?
No.
Okay, we all get 200. All right, so
Yes, sir.
let's check. Why do we have 200? Why do we have 200? Let's check.
It should be 100.
Okay, 20 multiplied by 20. Is that what you did? Because the area here is what? Okay, I guess what you guys did, because it's a triangle, and the area of the triangle is half base times height, isn't it? So we have 20 multiplied by 20 divided by 20, right? So okay, is that what I have? Divided by 2 rather. So this will be 400 all over 2. So that will give us 200 joules. Is that what you did, guys?
Yes, sir.
Oh, you're wrong. Sorry to tell you that. The answer is what?
It should be 100. 100. This is the first 10 meter.
Okay, so okay, just watch now. The question, Jamb can be so tricky. Jamb know that you know what you are doing. They know that you already memorized that once you see this graph, it is the area under the graph that is work done. And also I told you that, what was it called? The issue of failing Jamb is not only because you don't know book. It's because Jamb is tricky. Now let's go back to the question and solve it together. A force varying linearly with the distance acts on a body as shown in the figure. The work done on the body by the force during the first 10 minutes, 10 meter of motion is, so this is the first 10 meter of the motion. So you are considering the area under this place. And when you look at the area under this place, you are having what we call trapezium. Can you see that clearly?
Yes, sir.
So you're having a trapezium. And when you look at this height here, this is A, and this is B, and this is H. So you have that the work done is going to be 1/2 into what? A plus B multiplied by H. So the work done is going to be 1 over 2 into your A is going to be 10, that is this particular height, plus B, which is 20, multiplied by 10. Do you understand that now? So the work done is going to be, this will be what, 30. 30 divided by 2, that's 15. 15 times 10, that's 150 joules. So the correct answer is 150 joules. You guys understand this?
Yes, sir.
So
Yes, sir.
you see the way Jamb always jam people now. Okay? So you have to be very, very like you have to be so meticulous that you need to pay attention to details. Do you understand that now? You need to
Yes,
pay
sir.
attention to what? To details, and make sure you follow the questions one after the other so that you can interpret correctly. All right, so let's move on to the next question, and that will be question number 6. Now, for those people asking for graph and graphs this morning, you have seen how we are coming about graph now. All right. So the question here states that a body is under the action of a force such that the force displacement graph of the body is semicircular, as shown above. The work done on the body by the force in moving through 24 meters is okay. So listen before you start solving. You can see that they didn't express the value of pi. They leave their pi like that. So you're not putting the value of pi. Leave your pi like that. So let me hear your answer under 1 minute.
I think can you zoom the diagram?
Okay, I think I can do that successfully. All right, can you see the diagram clearly now?
Yes, sir.
All right,
Thank
so
you, sir.
okay.
You belong 445.
You said what?
72
72
pi
pi.
joules.
72 pi joules. That's option
Yes.
B. Is that what everybody have?
Yes, sir.
Yes.
Okay. So everybody got 72 pi joules. And that's the correct answer to the question. Okay. So people asking me of graph. Have you seen how Jamb is making use of the graph now? Okay. So let's move on to the
Yes.
next question now.
Sir, please explain how you start
solve it.
72.
Okay. Somebody said we should solve it. You know, since this is a semicircle, and the area under a distance, a force distance graph is work done, Abi. So that means that the area of the semicircle is the work done. That's 1 over 2 times pi times radius square. Or it should be 1 over 2 multiplied by pi. Sorry. Yeah, 1 over 2
Yes,
1
ma'am.
over 2 multiplied by pi multiplied by what? D square over 4. Are you getting it now? So any of it. Now, if I want to use this first one, then I need to find the radius. This is the center of the circle. Are you getting it now? A line drawn from the center of the circle to the part of circumference is called radius. That means from 12 to 24 is radius, which means that our radius is going to be 12. Are you getting it now? So I'll be having that the work done is 1 over 2 multiply by pi, then multiply by 12 raised to power 2. So that will give us 1 over 2 pi multiplied by 144. So 2 here 1, 2 here 72. And that is how we have that work done is 72 pi in joules. Do you understand that now? And if you want to use this formula, you can also use it. You just have 1 over 2 times pi multiplied by 24 square. Are you seeing it now? Divided by 4. And I'm very sure you also have 72 pi joules. Is that taken now?
Yes, sir. Thank you, sir.
All right. So let's move to the next question. And I think the next question here, okay. That's question number 7. All right, so let me quickly draw the diagram for this also. They say from the diagram above, so the diagram will be below here. You have to pay attention to this also. Sorry. Okay. Okay. All right, so I'm trying to draw the diagram here. Okay. So I have this. And okay, so I have this. Okay. All right. So and have this. So the question now states that I think this peak here is 80. So what I have here is force, and here is 80, and I have here to be 60. Okay, that's all. This diagram is not too clear like that. I have here 30. I have here 40. And I have here to be 60. Okay. I think that's how the diagram is. Just hope I didn't mix it up. All right. I think we should. So please permit me to skip this question. I'm not seeing the diagram clearly. But I think the question is in year 2012. Yeah. So let's quickly check 2012. It's a Jamb question in year 2012. Okay, yeah, this is it here. Can we see the graph? Guys, can you see the graph?
Not really clear, sir.
Yeah, it's not that clear. That's the problem I'm having too. So this is how the graph look. Although there is a mix up here. This 20 is supposed to be on this line here, and this 40 is supposed to be on this line here, and this 60 is supposed to be here. Are you getting it now? So you can just do well, check your past question, year 2012, and look at question number. I think the question is trying to see what number it is. Question number 11. Yeah, 2012 question number 11. So you can just try that on your own later. 2012 question number 11. Sorry, it will have been a fantastic question if we are able to look at it, but the diagram is just somehow. So but you can look at it and just give it a try. Is that taken? All right, so question number 8 now. All right, so we are on question 8 now. Are we there, guys?
Yes, sir.
Okay, so just say that which of the following. Okay, let me just zoom out so that you can see clearly. Okay. Sorry. So the question says that which of the following best describes the energy changes which take place when a steam engine drives a generator which lights a lamp? I said it now. Which of the following best describes the energy changes which take place when a steam engine drives a generator which lights a lamp?
The answer is C, sir.
The answer is what?
C. The answer
That
is
is
C.
okay. That is from heat energy
Heat to
to
kinetic to
kinetic to
electricity
electricity
and lights.
all right. So
I like.
that's brilliant. So brilliant. I believe everybody get this now. So let's move to the next one. And now the question 9. All right. So question 9 says a cage containing a truck 750 gram. So the mass is 750 gram. So 750 kilogram is raised to height of 90 meter. The height is 90 meter in 1 minute. The time that takes is 1 minute. What is the total power expended? So we can quickly do this for us. We'll quickly give it a try. We are rounding up already. So we have just 2 questions more to go.
One
1125. I think they present their answer in kilowatts.
Yeah.
So that should be
You see, sir.
11.25.
Yes, 11.25 kilowatts.
Okay, is that what everybody gets?
Yes, sir.
That's what we all get, right?
Yes.
Okay, so that should be correct. It should be correct. I don't know, but I think since everybody get that, and it should not go and be like the other one that everybody got that on the triangle, and it later turned to be the wrong answer. Okay, I'm just trying to see if it is correct instead of me solving it again. Just trying to check it out if it is correct. All right. All right, I think it should be correct. That is 11.25 kilowatts. So that's absolutely correct. All right, so let's move to the next question, which is going to be the second to the last question. So question number 10. The question says that a man weighing 800 Newton, that is the weight of the man, which we can call force of gravity, is 100 Newton, climbs up a flight of stairs to a height of 15 meter. So the height is 15 meter. In 12.5 seconds, the time is 12.5 seconds. What is the man's average power output? What is the man's average power output?
960 watts.
960 watts.
960.
Okay, it seems
960 watts.
that's very fast. Okay, that's correct. That's very fast. All right, it's a good one. All right, so the last one now. All right, I know this one is. You don't understand it.
Yes, sir.
Okay. So we have that a man weighing 800 Newton. So the force is going to be 800 Newton. Climb up a flight of stairs to a height of 15 meter. So H is given as 15 meter in 12.5 seconds. So the time that took the man is 12.5 seconds. What is the average power? So power is going to be what? It's going to be the work done, that is, or either work done or energy over time. So this is going to give you we have force here, we have height here. So force times height is going to give you the same. Force, which is the weight, can be mg, and h is equals to what? H. So mg times h can give you mgh, which is potential energy, and that's energy over time. So you have 800 multiplied by 15 divided by the time, which is 12.5, and you should be having 960 watts. Do you understand that now?
Yes, sir.
All right.
Yes.
Okay. So let's go to the last but not the least. That's the last but not the least question. The last but
Oh,
not the
thank
least.
God.
Is that
Somebody must speak. All right. So the last but not the least. Okay. That's question number 11. And the question states that A bulb weight is 0.1 Newton. Hangs on a massless string of length 50 centimeter. A variable horizontal force which increases from 0 is applied to pull the bulb until the string makes 60 degrees with the vertical. The work done is, so that's the question. So doing that for us.
So I'm asking a question that work done having degree. Oh.
Okay. Okay, now let's interpret this question together. I know it's going to be tricky a bit. We are told
Yes.
that a bulb of weight is 0.1 Newton. That is, the weight of the bulb is 0.1 Newton. Are we together now? So that means mg is equal to 0.1 Newton. So that's what is your, well, anytime you are given a question, even if you don't know what to do, interpret first. Are you getting it now? On a massless string of length 50 centimeter, the length of the string is 50 centimeter. A variable horizontal force which increases from 0 is applied to pull the bulb until the string makes 60 degrees with the vertical. Okay, so let's see what they are saying there. Let's say this is the bulb at initial stage. Are you guys following? This is the bulb here. And the length of this rope is given as 50 centimeter. I see this now. And
Yes.
later,
Yes, sir.
an horizontal force, this is an horizontal force here, is used to pull this object upward until it makes an angle of 60 degrees with the vertical. Can you see this now?
So I got it diagram.
Is that what?
Sanity.
Okay. So you can see the way we get the diagram now. So we are interpreting what we have here. So it means if you take from here down like this, so it means the body has what? Moved from this point, from this horizontal level to this point I. So we want to know the value of this point here, this h. Because if we are able to know the value of this h, then we can say work done is mgh. Do you understand?
Yes, sir.
All right, because yeah, you can say work done is equals to mgh like that. Now let me call this point P and call this point Q. I see it now. So the height at point P, the height at point P, let me put it like this. Let me put it as at P, the height is equal to 50 centimeter. Are you following?
Yes, sir.
Okay, but at Q, the height becomes, you can't know what this height will be at this point. Are you getting this now? We don't know what it
Yes.
is, but we can know what it is by knowing the value of this what L in line with this particular horizontal ground. Are you getting it now? So that is, I can find the value of this length right here in respect to this angle. And if I'm to look for that, I'll be having that what? I will have that h is equal to the length, which is this one here. Are you getting it now? This length, cos of theta, L cos theta. That is this 50 centimeter here, cos of theta. Am I making sense now? Remember, this is the length of the rope. So this is also the length of the rope. Are you getting this now? And its equivalent is going to be what? Is going to be h equal what? L cos theta. Now, if this should be the case, what is now the value of this height? So this height h that we really need is now going to be the difference between L and L cos theta, because this is the height that we really need. That's the work done. That's how far the body has moved from this ground level to this point. Are you following?
Yes, sir.
Yes, sir.
Okay, so this h will now be what? L minus L cos theta. So if that should be the case, the work done, which is equal to mgh, is now going to be mg is what? Is 0.1 multiplied by h, which is let me factorize out L. So we have 1 minus cos theta here. Am I making sense? So W is 0.1 times this length. Convert 50 centimeter to meter. You have 0.5. Abi? Multiply by 1 minus cos 60. So you have that done is 0.1 times 0.5 into 1 minus 0.5. So that will give us that the work done is 0.5 times 0.5 times 0.5. So what would that give us? That will give us the work done is 0.025 joules. So that's the right answer to the question. You get that now?
Jesus Christ.
No, sir.
Sir, no.
No.
Okay, let's take it again for the last time. All right, are we there?
Yes, sir.
We have that the weight of this body is 0.1 Newton. Are you getting this now?
Yes, sir.
Yes, sir.
And we are told that it is a massless string. When I say massless string, it means the string does not have the mass of the string is negligible, and the length of the string is 50 centimeter. They now said a variable horizontal force which increases from 0 is applied to pull the ball. It's just like you suspend something like this now. This is the ball. I seen it now. Let me make the line straight. Make the line straight like this, and the ball that you suspend. The length of this thing is L. Can you see from here, from this point to this point, the length is L, which is the length of the string. Are you following me?
Yes, sir.
This is the bulb here. Now, somebody now pull this bulb. When you split, this place is no longer there, but we know that something was there before. Are you getting it now?
Yes, sir.
So let's make it a broken line. Then when the person now pull it up, what's happening? When the person pull it up, it pulls to this point until the angle between this vertical line and where they stop pulling it is 60 degrees. Do you understand this one now?
Yes, sir.
Yes.
If you look at, this is the normal length of this is the normal position of the bulb from here now to this place. Now you have it here now. Let me cover here also. Can you see what happened now? You see that we are having a distance from here to this place, Abi, which is h. So this distance is how far the body has traveled. You know, the body is at rest before, no work is done. But when the body now move from here now to this place, work has been done. Through what? Height h. That's the distance. Are you following me?
Yes, sir.
Yes, sir.
And you know that the work done supposed to be mgh now, because we have mg already, Abi, and we already have h here, but we don't know the value of this h. So how can we get the value of this h? We can get the value of this h by saying, if I call here A, I call here B, and I call here C. So you can get the value of this h by saying that BC, I send it now by saying that BC is equal to AC minus minus AB. Do you agree with me?
Yes, sir.
Guys, this
Yes,
distance
sir.
here, BC is equal to what? AC minus AB. Now, what is AC? That is from here to this place is what? AC. That's equal to L, Abi?
Yes, sir.
Which is the same thing as saying 50 centimeter. But how can we get AB? We don't know. Are you following me now?
Yes, sir.
But
Yes,
remember
sir.
that this one is still letter L, Abi. It's still the length of the rope, isn't it?
Yes, sir.
Now, we have this length and we have this angle. How can we find this side? We can use the trigonometry ratio, isn't it?
Yes, sir.
And side AB is adjacent, isn't it? BO is what?
Yeah.
Opposite. And AO is what? Hypotenuse. So we can say cos of 60 is equal to adjacent, which is what? AB over hypotenuse, which is L. Abi?
Yes,
So if I
sir.
cross multiply, I will have that AB. If I cross multiply, I will have that AB is equal to what? L cos theta.
Cos theta.
I seen it now. So
Yes.
Yes, sir.
BC is equal to the H that we are looking for, isn't it?
Yes, sir.
So that will now become what? AC, which is L,
H
minus what? L cos theta.
cos theta.
So coming back to the original equation, we have that W is equals to mg, which is 0.1, multiplied by what? H. Our H is what? L. Let's factorize out L here. L can be factorized. So we have 1 minus cos theta here. Abi? So we have that L
Yes, sir.
into bracket 1 minus cos theta.
Minus cos theta.
So the work done is 0.1 multiplied by our L is 50 centimeter, which is same thing as 0.5, Abi? Into bracket 1 minus cos 60. Cos 60 is 0.5. You have 0.1 times 0.5. So we have 0.1 times 0.5 times 1 minus 0.5.
0.5.
Give us 0.1 times 0.5 times 0.5. And that will give us the work done to equal to 0.025 joules. And that will be option C.
C.
Do you understand that now?
Yes, sir.
I hope everybody gets it clear now.
Yes, sir.
Yes, sir.
All right, so
Yes,
I'm going
sir.
to drop the assignment inside the group now. I'll drop it on the group now so that I can attempt it. Make sure you do it. Are you getting it now? You're only submitting the options. Are you getting it? Right? A, B, C, whatever your answer is, you're submitting only the option. Type it, number it, number 1, A, number 2, B, number everything, and submit to the group. I will go through it one after the other, and I will score it and give you whatever you score. Are you getting it now?
Yes, sir.
Yes.
So, and if there's a particular question that virtually everybody failed, then we look at it together and see reason why the person people are failing it. Then we can now move on to the next question. So, in the next class, because of time, we just move to the next question, and the next question is we have that two balls X and Y weighing 5 gram and 50 kilogram respectively were thrown up vertically at the same time with a velocity of 100 meter per second. How will their positions be on 1 second later? So this question is underway. Who can tell us the topic it belongs to?
Scalar and vector.
Okay, somebody say scalar and vector. Which other person?
Scalar and vector.
Scalar and vector. Any other person? I hope you are not looking at this diagram. This is the question you are looking at. Too. This is the question. No. You want to
Okay,
highlight
this one.
like this? Huh? This is the question. No. Two balls, X and Y, weighing 5 grams and 50 kilograms respectively, were thrown upward vertically at the same time with a velocity of 100 meters per second. How will their positions be 1 second later? You can tell us the topic.
Be under motion.
It be about under motion. Well done. Well done. Well done.
Relative velocity.
Relative velocity. Okay. We have a lot of work to do. So, guys, don't try to miss classes. You paid and let your money count. So, the question, whenever you launch a body, launching a body has to do with what? Gravitational
Projectile.
field. It's a gravitational field. So,
As if I know.
that will be the first thing we are going to look at in the next class, gravitational field. All right. Thank you guys for making it up to today's class. I'll see you in the next class. Thank you.
Dans force, I have not.